This new theory of dark matter is adapted from my book, Universal Reality 2.0, available in a free PDF version at edgarallowen.com/reality_SHTML. Dark matter is an invisible gravitating substance postulated to explain the observed gravitational effects of the universe. Without dark matter, there isn't nearly enough mass in the universe to explain the rotation of galaxies, the strength of gravitational lensing, and the interactions of galaxy clusters. Based on its observed gravitational effects, it appears the amount of dark matter in the universe must be around 5 to 6 times the amount of visible matter. Theories. There have been many attempts to explain dark matter in terms of new undiscovered particles, but so far all have failed. But there's a very simple and obvious explanation that doesn't require any new undiscovered particles. It's well known that the universe has been expanding since the Big Bang 13.8 billion years ago, but this expansion is uneven. Only intergalactic space is expanding. The space within galaxies is gravitationally bound and doesn't expand. This uneven expansion of space causes the space bordering galaxies to warp and curve. But warps and curvatures of space are precisely what relativity tells us gravitational fields are. Thus, the uneven expansion of space naturally produces additional gravitational fields around galaxies, precisely where dark matter effects are found. So the warping of space due to the uneven expansion of the universe automatically produces gravitational fields around galaxies just where dark matter effects are observed. Thus it's reasonable to postulate that dark matter may actually be these warps in space produced by its uneven expansion. There are many advantages to this theory. This is a very simple and obvious theory with important advantages. First, it doesn't require any new undiscovered particles outside the standard model. Second, it's automatically dark and invisible since there aren't any particles involved. Third, it's created at galactic boundaries, precisely where dark matter is necessary to explain observed gravitational effects. Thus, the theory appears very natural and compelling. And once dark matter warps form, they behave as any other gravitational field and move around under gravitational interactions just like other masses do. This explains the presence of dark matter in other areas. Implications. Note that in this theory, the amount of dark matter in the universe should increase over time as space progressively expands, increasing the warps. In addition, the added gravitation of dark matter leads to ever more warping, increasing the amount of dark matter even more. There's actually evidence that the amount of dark matter has increased with time from ESO. We know that warps in space are gravitational fields, and we know the uneven expansion of space should produce space warps. If these warps aren't dark matter, then what are they? The only possible thing they can be is dark matter. We see no other effects. A testable theory. This new dark matter theory is testable by running supercomputer simulations of galactic gravitational interactions backwards in time to see if dark matter originally forms as galactic halos and then moves under gravitational interactions to its current locations. However, one must always be careful with simulations as they can be programmed to produce nearly any desired result. Summary. Universal reality presents a reasonable and testable new theory of dark matter, compatible with its new complete theory of everything. In this theory, dark matter is a natural effect of the progressive uneven expansion of space. If this theory is correct, it implies that the progressive expansion of the universe inevitably leads to a slow exponential increase in its gravitation. This could eventually reverse the expansion, leading to a collapse into a universal black hole. If so, there are not natural mechanisms by which this collapse to a universal black hole might result in a big bounce. These are explained in my book, Universal Reality 2.0.